Alright, imagine this. You and your friend are on a bus and you guys are traveling down a hill. Hey, do you even know what those percent signs mean? Like, there's a truck on them, but what does that mean?
That's gradient. It's used by the government when they aren't busy watching you. The gradient is basically rise over run, but in terms of percentage. In this case, it'd be 18 feet of vertical change over 100 feet of horizontal change.
The hill's not 100 feet run. How can we possibly solve this?
They still have the same percentage, but we can solve for the altitude difference.
How?
By using the trig ratios. For example, we would use the tangent ratio, which is opposite over adjacent, to find the rise, since we already have the slope.
But we don't have slope.
Yes, we do. The sign says 5 miles.
So, how many feet is that?
26,400 feet.
How do you know that?
I am the government, and I am the state.
What?
Sorry, flashback to Euro. So anyways, 26,400 feet.
Try to find x, you say. X, we can find it through the gradient. Now, we know the angle. We can find the angle by using the tangent ratio, which is tangent theta, and as we all know, tangent is opposite over adjacent, so 18 over 100. Now, to solve for theta, we use inverse tangent. And plugging that into our magic calculator, we get an angle of 10.2. So now what do we do with this? Well, we plug it in. We have angle 10.2. Now, how can we use this to find x? Well, since we know the angle and we know the slope, we can use sine to solve for the opposite. Sine is sine theta equals opposite over hypotenuse. So we know our hypotenuse is 26400 feet, and we know our angle is 10.2. So now all we have to do is find x. So how do we find x? X equal sine theta times 26400 feet. We get sine of theta, which we found from tangent, multiplied by 26400, and we get 4676. X equals to 4,676 feet.
Don't you think it's kind of weird how you didn't know what I was talking about, yet you were able to solve the problem relatively easily?
Are you implying that there's some kind of consistency error with the video?
I'm not sure I understand.
Never mind. Hey, is that another gradient sign?
Why, yes it is. That's weird. Why wouldn't they just make one road, with one slope, with one probably lower gradient?
Beats me.
Hey, why don't we just design a new road? We are just a bunch of high school geniuses after all.
Yeah, I can count a potato.
Okay, so what we're going to do is find the angle of ACD. We're going to do that by taking, we're going to be using trig ratios. So we're going to be using the trig ratio tangent, which is going to be opposite over adjacent. So that's going to be 14 over 100. And to find the actual measurement, we're going to take the inverse of tangent, 14 over 100. And as I've already done here, that's going to be roughly about 8 degrees. Okay, so now we're going to find the length of line AD, which is going to be here, highlighted in pink to make it easier to see. Alright, so we're going to take the sine of the 8 degrees, or I guess the angle we found earlier, of ACD, and we're going to use the trig ratio of opposite over hypotenuse, so that's going to be line AD over the previous value, 10,560 feet, which is actually just 2 miles. Okay, now we're going to multiply both sides by 10,560 feet, and that's going to give us this. And if we plug that into the calculator, that gives us roughly 1,470 feet. Now that we have this length here, right, we could find the total length of UB, which is going to be here. We can find the length by adding together the two values of 1,470 feet. I'll get these together. That's going to be 1,076 plus 1,470. That should give us plus 1,470. UB is about 6,146 feet. Okay, so first things first, we're going to find line segment AE, which is about here, and then here's what we're really looking for. So what I'm going to do is use the Pythagorean theorem. So you could see a UA squared, which is the hypotenuse, subtracted by the other leg of UE squared, and you substitute the values and you plug it into the calculator and see. Okay. Oh, it's actually supposed to be a 6. Okay. That gives you this value, so it's actually an estimate of about 25,982. Yeah, take that. Okay, and the next value you're supposed to find is this one here. CD, like that. Okay. Same thing. We're going to be using the Pythagorean theorem. AC squared here for the hypotenuse, and AD squared here for the leg. We'll subtract that. This is kind of like derived from the Pythagorean theorem. Anyways, you take this and you plug it in again. 10,560 squared minus 1,470 squared, and you get this value, 10,457. Yeah, roughly. Well, now we need to find the value of CB, right? So we'll find that by adding up the length of AE and the length of CD. Okay, so we'll get 25,983 plus 10,457, and that's going to give us, let's say, CB. So CB is going to be, okay, plug that into the calculator, 25,983 plus 10,457. That's going to give us 36,440. That's going to give us roughly 7 miles. So, okay, so the new road we have is going to be about 17% gradient over 7 miles, so the next 7 miles. So there you have it. That's the new road.